Bach-y-Rita thought, well, I guess the damage wasn't that bad. Even he couldn't believe what he discovered. But 20 years later, his father died of a heart attack while mountain climbing. They did an autopsy on his brain and found that 97% of the part of his brain that connected his motor movement to his spinal cord was destroyed. So somehow he retrained the brain, other parts of the brain, to take over those functions of his arms and legs. And this is one of the fingers I keep coming across by reading brain studies, that movement and learning, if paralysis is permanent, you'll never regain use. And that's what the doctors told him. Now this smart aleck didn't believe it. He thought, somehow I must be able to train my father to walk again. 8 million parents have bought or something like that. And Baby Einstein is basically a video series that's very cute and attractive that teaches children words through audio and visual images. Later research found children who watch Baby Einstein learn fewer words. Babies were allowed to just crawl around and touch things and pick things up and talk with their mothers and do other normal things. So Baby Einstein is actually a non-anti-learning device. I think the company's being sued now. Apparently, for each hour per day, there'd be 7 less words learned. So, why is that? Because babies need to touch things to learn. They need to move and manipulate and touch. And I've noticed myself, taking notes, even if I never see them again, I'll remember much more. And other studies have found too that people writing things down. There's a study in Britain that showed that people chewing gum while they're studying something retain 36% more than people who don't chew gum. So movement. Well, our brains evolved to move. And that's actually why when you're in conferences like this, you feel kind of sludgy now because you've been sitting the whole time. Our brains evolved out of moving bodies. And it's because your blood flow is too low to remove all the glutamates from your brain. So actually our classroom should be on jogging machines. People learn a lot more. And there was research that found it. There's a study with, let me get the numbers right, 5,000 elementary school students where their study time was cut back 30 minutes and 30 minutes twice a day. They're replaced with exercise activities twice a day for 30 minutes each. Their scores went up in every area, especially the girls, especially in mathematics, high cognitive processing skills. Also the notion that our brain is a separate thing that can exist in a jar doesn't exist. Your brain extends out to your fingertips and your toe tips. And even your car or your house, your clothes, if you think of the body map approach. And people like Brown and Murphy are doing research on this and the importance of moving for learning something. For example, they talk about one study where there's patients where people are given these glasses that reversed the field of vision. So everything on the right was on the left in these glasses. It really threw people off for a while, but after about 2 days, their brain would suddenly reprogram so they could see everything in the right place. But that would only happen if they could move and touch and manipulate things. They had those glasses on forever, but they wouldn't move. They would reprogram. So, fingers pointing at strange facts, the importance of movement and learning. Well, the second person I'll talk about is the outcast, Edward Tao. He did something fantastic for many people, but he was also an outcast. Edward Tao was doing research with monkeys. Now, monkeys have 3 bundles of nerves that go through their arms: sensory, motor, and But it was found at the turn of the century that by cutting the sensory nerves, not the motor nerves, the monkey would become paralyzed with that arm. Well, Taub did experiments like that and found that if he cut both arms' sensory nerves, they'd regain full use of both arms. That's odd. And he began to believe there's something that the brain does called learned non-use that tries to move it, after this injury, it can't, so it gives up. It learns that it can't move its arm and remembers it that way. Then he started doing experiments where he would tie down one arm, with the monkey and the good arm, and cut the sensory nerves in the other one. And the monkey would regain use of that arm. And this led, later, to a fantastic therapy for stroke victims. And stroke victims and people with spinal injuries, where instead of training the good arm to take over the functions of the damaged one, they tie that one down, force the person to jerk that arm to regain use of it. And the regained use is from 80 to 90% or so in most cases for people like that. But we didn't get that study for a long time because something happened to Edward Taub. One of his research assistants in 1976 was not a real researcher. He was the president of KITA, the Animal Protection Group. That group has done a lot of good things for the world, but this time they broke into his laboratory on summer vacation. He was in Europe. They staged some photos. And when he came back, he was arrested for mistreatment of animals. This is one of the photos that they took. He said, I never mistreated the monkeys like this. This was a staged photo. It was proven later. And so all of his monkeys were taken away. And actually, that's when the first one died in Peter's care. He was in outhouse for 10 years. All his funding for his research was cut off. Just on the brink of this discovery, all his research funds were cut off. He lost his job. It took all of his personal fortune to clear his name, which happened 10 years later, even though many scientists gave him support. He couldn't continue his studies until about 10 years later when he developed that technique I just talked about. Well, just on the side, I don't know the morality of injuring a healthy monkey's arm, how that weighs against the possibility of making a fine that will save thousands of people from this situation. But a curious thing happened when I was preparing this presentation. I was thinking, I remember, in 1986, 84, my father had a massive stroke. He became paralyzed in both arms and legs and voice. And he was given a traditional therapy. And of course, he was paralyzed then, so he died 7 years later. But if Taub had been able to make his findings known 10 years earlier, my father probably still would be here today. It's kind of a curious thing for me. But the point is, Taub's finding, this research, shows that there are no limits for what the brain can do. And we can retrain the brain in various ways. And the notion of people getting old so they can't do things anymore, that's not true either. People are finding now new methods to improve your memory as you get older, rather than just save it. And that brings me to the third person, the Mother Teresa, the man who has used brain studies to help people with autism, people who are aging and losing their memory, and people with deafness to retrain their brains in ways to overcome those deficits. That's Michael Wurznick in California. Now, what he found was interesting. Back in the 70s, he was analyzing brain areas and studying brain areas, which found out what area did what. That was a popular research topic at the time. And our brains is divided up into little areas that control different functions. For example, your fingers, each finger is controlled by a different brain area, and they're all lined up right next to each other. Well, he found that these brain areas sometimes change shape or change position, which went completely against the hardwired notion. He found that if he tied a monkey's fingers together for long enough, the brain areas for those fingers would merge into one. So this led him to the realization that brain areas are constantly competing for use of neurons. They're taking neurons away from each other. This led to two important discoveries, three. One, use it or lose it. If you don't get a certain amount of input or use of a certain nervous stream, other parts of the brain will take it over. And Shanghai those nerves. The other, and this is even more interesting, neurons that fire together, wire together. So two completely different experiences will become combined in our neural circuitry. An example, excuse me for this example, it's such a good one. Example is masochism. There are people in the world that get sexual pleasure out of physical pain, like driving a nail through their hand or something like that. It's not a psychological craziness. It's actually something with their brains that gives them sexual pleasure from physical pain. Well, it was discovered every single one of these severe masochists at the age of 2, when their sexual area of their brain was forming, were suffering from some chronic illness or disability that caused chronic pain the whole time. So pain and sexuality wired together during a critical age. So these things, pain or sadness or emotional things, wire into things that we're developing. What does that mean in relation to high school or junior high school education, critical age for learning language? Are we training our students to hate English in high school because we give them so much pain in the classroom? And maybe not all, the ones that are successful, they get them. Like the video that Andrew Finch showed this morning of those two guys, the gangster son of the president, the two fighters that can never learn English later? Or are they going to be like people I meet in Japan? They're all goes, hi, how are you? They say, panic mode. Well, the third important thing that he taught us about the brain, learning is critically related to reward. And it's related to reward because reward is really the release of dopamine, serotonin, acetylcholine, and other neurotransmitters. The same neurotransmitter, dopamine, that's the interesting thing. The same neurotransmitter that causes us to feel good or feel reward or be motivated or gives us focus is also related to permanent learning. How nerves go from short-term to long-term memory. And it works like this. Eric Kandel explained that. Eric explained it first. When a synapse fires repeatedly, it causes dopamine to be released. Dopamine goes into the nervous cell, causes a protein to go to the nucleus and turn off a gene that causes synapses to shed later. So it causes a permanent connection, and also new synapses.
What about long-term memory? What happens if we stimulate repeatedly? When we stimulate repeatedly, we reach the threshold of a modulatory system which releases dopamine. Dopamine is a modulatory transmitter like serotonin. It acts to alter synaptic strength in neurons in the brain, and it is altered in its activity in a number of diseases, Parkinson's disease, for example, and in schizophrenia. When dopamine gets recruited, it acts on a dopamine receptor that is coupled to an aminol cyclase that increases the level of cyclic AMP, activates the cyclic AMP-dependent protein kinase, it activates CREB. CREB acts on downstream genes, and that gives rise to the growth of new synaptic connections. So the long-term memory shares a number of components in implicit.
Okay, Eric. That's good stuff, actually. If you get a chance to listen to it on YouTube or visit his own website. But again, there's fingers pointing at things we never thought about in relation to language learning, like happiness. If dopamine, the neurotransmitter of happiness and reward, is related to permanent learning, does that mean that things that we like, we learn better? That makes sense from evolutionary terms because our brains are built for us to survive. And our brains want to remember the things that are good for us, like where that last source of food was. But we never think about happiness or pleasure as a part of learning. And in my opinion, that might be why extensive reading is effective, because it's enjoyable interaction with language. And so that language might relate to dopamine release and deeper interaction internalization. I talked to Dick Day about that. We look at it, it's crazy. But there are so many interesting things in there. So, I got interested in studying the reward system of the brain. Because the reward system of the brain, just knowing it existed, is related to dopamine and dopamine release. These are strands of nerves that are highly dopamine sensitive and highly plastic. They're related to why we become addicted to drugs. Because we're so happy. Dopamine gets released, we get super addiction is really super. And dopamine, again, related to desire, reward, motivation, focus, and other things. And here's something interesting. There are actually 3 strands that the reward system goes to, that connects. One is the thinking part of our cortex. There's the movement part, there's movement again. And the other is the emotional part of our cortex. So emotion and thinking and permanent learning and movement. Again, it shows there's some kind of connection. And especially emotion, because the emotional center of our brain is also the part of our brain that controls memory formation. Our emotional center is always looking at information that's coming in and deciding whether it's relevant or not relevant to us. And relevant information is tagged for attention. But the point is, another finger, pointing towards happiness and attention, these things that we don't know about yet that might revolutionize our field. But here's something else interesting about dopamine. If you make somebody happy the same way again and again, first you get happy, you release dopamine. But after a while, your nerves stop releasing dopamine. There's another factor for dopamine release is novelty. And we know from research that novelty and learning are closely connected too. Let me ask you a question. On my title slide, there were 13 words. One of the words was misspelled. No, don't tell me what it was. Yeah. One of the words was misspelled. Remember that word? Don't say it. Remember that word? Does you notice it? No. Okay, people who notice that word, you know any of the other 13 words? Yes. Yes, probably some, but you will retain. It was brain. Sorry, I should let you say that. What word was it, sir?
Brain instead of brain.
I had brain instead of brain. And it's very likely that you would remember that word and during this presentation, but probably none of the other words unless you notice that my name was up there or things like that. So again, the novelty is an important part of learning. Beyond a comprehensible input to our language acquisition device. So there's been something missing in our theories, and it bothers me. What are we going to find out in the future about the importance in terms of acquisition or retention in relation to finding, in relation to sharing, making, moving, or just how language is used for itself? And language evolved for a reason, so we could socialize, so we could connect with others, so that we could love, so we could make our world safer. And none of these things are in the basic theories of how the brain works. We're getting there. And I have to say, I learned today from Professor Kim that even Krashen is modifying his theory out, not just comprehensible input. He's also talking about compelling input. So, congratulations for that. Well, I hope we can find more things, new discoveries, and find that what I found in the classroom makes students happy, makes them learn better, and makes them happy. So thank you very much.
Thank you.